Graph simple rational functions. A rational function has the form f of x equals p of x divided by q of x, where p of x and q of x are both polynomials. And of course q of x can't be 0 because then you would be dividing by 0. The graph of the parent function, f of x equals 1 over x, is a hyperbola which consists of two symmetrical parts called branches. These here are the branches. Any function of the form g of x equals a divided by x, as long as a is not 0, is going to have the same asymptote, domain, and range as the function f of x equals 1 over x. It will look very similar, but the branches will have a bit of a different curve. Also, note to remember, as you can see, the vertical asymptote and horizontal asymptote are both related to the domain and range, which domain and range cannot be 0. Another way to get the domain, the vertical asymptote, is to set the denominator equal to 0. Graph f of x equals 5 divided by x. As we said earlier, because this is the form of a divided by x, we know the vertical asymptote is x equals 0. And we can graph that and just make it a dashed line. Use a straight edge. The horizontal asymptote is y equals 0. Graph that. Make sure you use a straight edge. And since we have the asymptotes, the domain and ranges are related to those. So the domain is that x cannot equal 0. In interval notation, it would look like this, where we have the negative numbers first. Then we're excluding 0 with these parentheses, and we're combining it with the positive numbers. The range is that y cannot equal 0, and in interval notation, that would look like this. All right, now we need some points to graph. So, pick numbers that are simple, straightforward. I'm going to do my best to go in order here. Again, you can pick whatever you want, but if you pick numbers that are multiples of 5 or factors of 5, in this case, which is the numerator, it might be a little bit easier. So I'm going to try going in order. So if I substitute negative 10, 5 divided by negative 10 would give me negative 1/2. Negative 5 is a good one. Negative 5 gives you negative 1. Negative 1, good point. We could also substitute fractions, 1/2. 5 divided by 1/2, or 5 times the reciprocal, 2, gives me 10. And 5 divided by 1 is 5. 5 divided by 5 is 1. And if I substitute 10, I would have, it would look like this. This is the work that I'm not showing. And that would simplify to 1/2. All right, now we just have to plot these points and connect them. And this may not be enough to make the graph that you want, so you could always substitute more. If you substitute 2, 5 divided by 2 would give us 2.5, so that'll be right there. You could also substitute 2.5 to get 2. All right, and if I substitute negative 2, 5 divided by negative 2 gives us negative 2.5, so negative 2 is at negative 2.5, and negative 2.5, and now we have enough points to make a better graph. And then when you connect it, just connect it as carefully as you can. You don't have to, anything that's too far away, you could leave it. It's your call. So here it is, it's approaching the asymptote on both parts. then the one in the third quadrant, and if you want to include the 10 and 1/2, those you can, or that's good enough right there. Let's talk about end behavior. So where is this, as we're going towards infinity and negative infinity, what is going to happen to the y value? Well, on the left side, we could see that the y value is going to approach 0. And erase that. So therefore, as x approaches negative infinity, f of x approaches 0. And as it approaches positive infinity, f of x approaches 0 as well.